Okay. So for section 1.1, linear functions and tangents, we're talking about slope, which it's nothing new to you guys, but slope is actually going to be like a very critical concept for us for this course, because once we get to derivatives, you do need to understand that derivatives is all about finding slope at any given point in whatever curve that you're talking about. Okay. So this is written slightly differently than you're probably used to. You're used to slope being, rise over run, or y2 minus y1 divided by x2 minus x1, which, like, all of these are the same, right? The difference between y2 and y1 is just reporting the change in y values, whereas the difference between x2 and x1, that's just reporting the change in the x values. Okay, so slope is also called the average rate of change of y with respect to x, or in other words, how quickly does y change in relation to x. So let's just highlight that slope is an average rate of change here. Okay, so note, if the change in y is positive, then y is going to be increasing. If the change in y is negative, then y is obviously going to be decreasing there. So for our example, we're given a linear function 32x plus 12y minus 19 is equal to 0. If x decreases by 2, by how much does y change? Okay, so like starting off with just going back to the slope equation. Okay, I'm starting over here just because I'm gonna pick up here eventually, but I need to do some work first. But I find that this kind of helps explains why I'm doing what I'm doing. Okay, so since it says if x decreases by 2, so if we know how much x decreases by, we know that the change in x is equal to 2. Okay, so let's just write that over here. So then the change in x is equal to negative 2. Okay, so you guys should all be aware that whenever you're given any equation, you can find slope from that once you put it into y is equal to mx plus b format, right? So we're going to be able to find slope eventually. We already have change in x, okay, and we'll need to isolate for change in y eventually, okay? But right now, since we already have change in x, we just need to find slope first from the equation given, okay? So hopefully that kind of describes my game plan as to what I'm thinking before I really get into it, okay? So 32x plus 12y minus 19 is equal to 0. So I'm going to get y by itself. I'm going to choose to subtract 32x and add 19. So 12y is equal to negative 32x plus 19. We're going to divide everything by 12. So y is going to be equal to, so I'm going to simplify this fraction already. So 8 divided by 3, x plus 19 over 12. Okay, so we know from here that our slope is negative 8 over 3. Okay, so now what we can do is we can plug that value into what we were talking about over here, okay, when we're discussing the game plan. Okay, so negative 8 over 3 is equal to change in y divided by change in x, which we said change in x was equal to negative 2. So that's what I'm going to plug in here. Okay. So if I times both sides by negative 2, what we're going to get is positive 16 over 3 is equal to the change in y. Okay, so what we can say is y increases by 16 over 3 units. Okay, so quick review about slopes. Now we're going to move on to tangent slopes. So a tangent line, or a line tangent to some curve at point P, is just a straight line that's going to satisfy the following conditions. So it's going to touch the curve only once at whatever point P is on that curve. Okay, and the slope of the tangent line is going to be the same as the slope of the curve, but specifically at that point P. Okay, so off to the right, beside this little blurb, they're drawing out the tangent lines that only touch whatever curve they're talking about at point P. So that's what's happening for that circle. That line T only touches at point P, and same thing with the parabola. The tangent line only touches at point P. So with this activity, you're going to need some sort of straight edge, so you can get your side of your calculator, or if you have a ruler handy, and then just draw a straight line just so it only touches at point P. So I'm going to try my best here. Ooh. I might have to scooch this over a little bit. It's being a little sticky. There we go. That's going to have to be as good as she gets for that one. Now with the middle one, since point P is right on that line, our tangent line is going to be right over the line that's being talked about. Okay. And then with this last one, be right about there. And they're meaning point Q, draw a tangent line, at point Q. So I'm gonna have to adjust this one here. Oh, it's being a little bit sticky. There we go. All right. So what we're going to be getting into are tangent slope problems, okay? So from our previous slope equation, right, you need 2 points, a point 1 and a point 2. That's where y2 and y1 and x2 and x1 come from. However, the problems you guys are going to run into is that you need 2 points in order to figure out slope. However, you're only going to be given 1 point. Okay, so the question is, how on earth are we going to figure out slope if we only know just 1 point here? So on the next page, that's where we're going to apply this problem-solving process here. So for the function y is equal to x squared minus 5x, estimate the tangent slope at the point P to -6, and include a sketch of the general secant line and the tangent line. Okay, so we only are given 1 point, and we're going to use the secant line to help us figure out the slope of the tangent line. Okay, now what I find is helpful is just kind of writing out a little bit of a game plan here to show where we're going to go, and then we'll get to it. So that's what I'll write in this top right-hand corner here. So, game plan. So we are going to sketch the function that we're given, y is equal to x squared minus 5x. And to make it easier for us to sketch it, we're going to need to factor it so we can figure out where the x-intercepts are. We know it's a quadratic equation, so we know we're going to have a parabola. We know that the coefficient in front of the x squared term is positive, so we know it opens up as well. Okay. So step 1, factor given equation. So that we can easily sketch. Okay. Step 2, we're going to find the slope of the secant line that we're going to draw. So maybe I should say draw secant line and then find slope. Okay. Now for step 3, what we're going to do is we're going to approach point P from both the left and right hand side of point P so that we can help determine the slope. And then step 4 is we're actually going to determine the slope. So point P, remember that's where your tangent line touches the curve. Determine slope. There we go. Okay. So step 1, y is equal to x squared minus 5x. If we factor that by dividing both terms by x, we're going to go x times by x minus 5. Okay. And like I said before, we know that because of the coefficient on the x squared term, we know that because it's positive, this parabola opens up. And the x-intercepts, as x-intercepts at x is equal to 0 and positive 5. So what I'm going to do, I'm just going to quickly draw a little Cartesian plane here as best I can. I'm going to draw my x-intercepts at 0, 0, and we'll say that's where 5, 0 is. Okay, actually, you know what? I'll scooch this x-intercept just a little bit over to hopefully make my life easier. And since this is just a sketch, I'm not too worried about where the vertex is, because that's not terribly important. Okay, the important part is the general shape of what this parabola looks like. Okay, so looking back at the question, it says we have a point at 2, -6. Okay, so gonna take a look here, and we'll say approximately that's there. This drawing may not be to scale. That gets the job done well enough. And maybe I'll scooch over where I'm talking about my coordinates here. Okay, and then let's just draw that tangent line there. There we go. So there's our tangent line. So the tangent line, that's what we're trying to find the slope of. And in order to do that, we need to draw a secant line. So secant line, that just means that it's a line that touches a curve in 2 spots. So I'm going to choose arbitrarily to pick my second point, which I'm just going to label Q. You can label it whatever you want, but the reason why I am putting point Q for my secant line in quadrant 1 is so that the x and y coordinates for the secant line, both of them are going to be positive, and it just ends up making your life a lot easier for substitution. There we go. So this is secant line. Oop. Okay, so for the secant line, the coordinates of Q, we have no clue what those are. However, we do know that point Q is on this parabola, and we know that this parabola has the equation y is equal to x squared minus 5x. So that means we know the coordinates of Q are going to be x for the x coordinate, and then for the y coordinate, it's just going to be the equation. Okay? That's where I'm getting my information from. So x squared minus 5x. And you know what I'm going to do? I'm gonna write that as a note, that little extra reasoning as to why I put it in quadrant 1. So the reason why we draw point Q in quadrant 1 is so that your xy coordinates are both positive, and it will make subbing in easier. Okay, just gives you less to remember. Alrighty. So, step 2, we drew the secant line. Now we need to find the slope of said secant line. Okay, so I think I'm gonna put step 2, maybe start up here. No, step 2. Secant line slope. So remember, slope is equal to y2 minus y1 divided by x2 minus x1. Okay, now arbitrarily, I'm going to say that point P, which I should be labeling here, so that 2, negative 6, I'm just going to say that that's my x1, y1, and then point Q, I'm just saying that's my x2, y2. Okay, so hopefully this makes your guys' life easier. Okay, so y2, that's at x squared minus 5x minus y, so that's coming from point P, so negative 6, divided by x2, which is going to be x, because that's coming from point Q, minus 2, because that's coming from the x-coordinate of point P. Okay, so simplifying here, we got x squared minus 5x plus 6 divided by x minus 2. Okay, now we want to make sure that this fraction is as simple as she's going to get. Okay, so that means that we have a trinomial. There's no greatest common factor to pull out, so we need to go to our multiply and add to table. So we're multiplying to 6, we're adding to negative 5. Now the two numbers that multiply to positive 6 but add to negative 5 are going to be negative 2 and negative 3. Okay, so since our coefficient in front of x squared is 1, that means we can factor by inspection. So we can go straight to x minus 2 times x minus 3 divided by x minus 2. We have a common factor in the numerator and denominator, so we can cancel those out. So we can say that the slope of secant line PQ, that's going to be x subtract by 3, but x does not exist at 2. We have a point of discontinuity there. Okay, so I'm going to put a light blue square around this just to show that that's like an intermediate answer here. Okay, so step 2, we just found slope of the secant line. Okay, now step 3, we need to approach point P, so that guy right there. Okay, we need to approach that from both the left and the right hand side. Okay, so I think what I'm gonna do, I might have to squeeze it right here. And step 3. Approach point P, which is 2, negative 6, from left and right. Okay, so easiest way to do that, just make a little chart. So, actually, hang on 1 second. Approaching x is equal to 2 from the left. Approach x is equal to 2 from the right. Okay. So we got our x value, and then we have x minus 3. So this comes from that slope of our tangent line. Okay, so approaching from the left, so just to kind of help you visualize, approaching 2 from the left means we're going like this, okay? So my x value for approaching from the left, I'm going to start at 1.9, okay? And what I'm going to do for subsequent values is I'm going to get closer and closer just little by little to x is equal to 2 from the left here. Okay, so if you put 1.9 into x minus 3, okay, what you're going to get is negative 1.1. Okay, if you put 1.99 into x minus 3, you're going to get negative 1.01. you put 1.999 into x minus 3, so your slope for your secant line, you're going to get negative 1.001. Okay, so what we can conclude here is as we approach 2, okay, we approach negative 1. Okay, or our y value, sorry, approaches negative 1. Or sorry, not your y value, your slope, my bad, approaches negative 1 as you approach 2 from the left. Okay, let's do the same thing over here. So your slope for your PQ. Okay, but now we're approaching 2 from the right. Okay, so I'm going to go 2.1, 2.01, 2.001. So again, just getting slowly closer and closer to 2 from the right. Now, subbing in 2.1 into x minus 3, we get negative 0.9. Putting in 2.01 is going to give us negative 0.99. And then we get negative 0.999 if we put in 2.001. Okay? So what we can conclude from this is as we approach 2 from the right, our slope is going to approach negative 1. Or our slope of our secant line approaches negative 1. Okay? So what we can say in conclusion, this will be your step 4, okay, which is the determine slope part. Okay, so step 4. As x approaches 2 from both the left and the right hand side, slope approaches negative 1. Okay, now remember, your slope of your secant line, so this blue line here, as point Q moves closer and closer and closer and closer to point P, what that means is your secant line, the slope of it, slowly becomes closer and closer to the slope of the tangent line. Okay, so that's why we can put that as x approaches 2 from both the left and the right side, slope approaches negative 1 of your secant line, which is PQ. Okay, so that must mean, so the slope of your tangent line is equal to negative 1. And that's our final answer, so I'll put a dark blue box around that. All right, for our next example, determine an expression for the slope of the general secant. Don't sketch it. Y is equal to x cubed minus 5x plus 4 at the point P316. All right. Okay, so we know in order to get our answer, we need 2 points. Okay, just like how we did this previous one. We need our point P, we need our point Q in order to figure out the slope of the secant line. So we got our 2 points. P, which this question says is at 316. And Q, which this question says that our equation is going to be y is equal to x cubed minus 5x plus 4. So similarly to how we did this previous question, the coordinates for point Q are going to be x, and then the y coordinate will be the equation that we're given here. There we go. So finding that secant slope. So slope of PQ is equal to y2 minus y1 divided by x2 minus x1. Okay. So again, I'm just labeling this as my x1, my y1, x2, y2, and then let's substitute that in. So we have x cubed minus 5x plus 4 minus 16 divided by x minus 3. Okay, so we're going to simplify where we can. X cubed minus 5x, that's going to be minus 12, divided by x minus 3. There's no way for us to easily factor the numerator there, so what I'm just going to add to this is going to be, x does not exist at 3 because of the denominator. Okay, and that's it. That is our expression for the slope of the secant line. So that one's a whole lot easier than the previous one there.